So hi everyone again. I think maybe it's time to start our next presentation. So let's maybe wait for a couple of minutes because maybe we need to admit some people. So let's just wait for 2 minutes more and then we'll start the second presentation. So I think it's time. So let's start our second presentation session for today. So I'll be presenting actually today with Nishan on informing decisions on reservoir operation using satellite remote sensing. So as I said, this final presentation session will be a kind of integrating all the works that we have shown during this workshop to see how can we build a decision support system and how can we inform the operation of reservoir using the satellite remote sensing. I'll be showing you, as I said yesterday, the NiBRAS system, which is a system that I developed for the Nile River Basin, but it's still like a kind of in progress. So it's not completely developed, and I'm still working on it, but I'll show you some of the functionality of this system and how it works. And then Nishan will join us at the end of the presentation, showing you more and more systems that has been developed globally. And I think he will also show you this reservoir assessment tool, which is running every day for the entire world. So he will show you these tools and other tools as well. So I'm showing you an image. This image is a very recent image for the GERD, the Grand Ethiopian Renaissance Dam. And it's showing, it's only 2 weeks between the two images. And what actually I want to kind of like sharing from this image that the satellite can give a very good indication on how the reservoir is being operated, or even for the case of the GERD, how the reservoir is being filled. So which is something I think interesting, even if maybe this is not the filling phase of the GERD. Maybe the GERD was not filling at that time. It was just kind of like the high precipitation that comes in the summer. But I mean, even in the future, when the GERD will start filling, I think the satellite will be a very good tool to monitor how the filling is happening in the GERD. So this is maybe the last slide I showed yesterday in my presentation. I just want again to come to this slide, and as I said, one thing we want to do is to bridge the science and the decision making. And we are doing the research. We are using remote sensing. We are using models, machine learning. All of this we are using it. But the question is, how can we share these results with the stakeholders, with the people who are making decisions, especially the dam operators, the water managers, the farmers? How can we do all of this? So we need to kind of bridging this gap between the research and the practice. And so the vision here that I'll be sharing is to build the satellite-based decision support system. And as I mentioned, and this is, I think, the key of this workshop, that most of the developing nations, we have a challenge with sharing the in-situ data. So that's why we are kind of moving towards using the satellite and for sure validating first these satellite approaches before putting it into a decision support system. And so building the satellite decision support system to advise the reservoir operation. And in my case, it will be the Nile River Basin, but we'll be showing it for other basins as well. So I will be showing the NiBRAS system. And I will show one tool that I just developed this summer. It's called MRI2. So MRI2 stands for Monitoring Reservoir Initial Impoundment. So it's account for the future dams, but for now I just did it for the GERD. So using satellite, can we kind of see how GERD is being filled or not? And then Nishan will come in showing you kind of scaling these applications up to global applications like the reservoir assessment tool, and he will show also other kinds of tools. So what is the goal when we say like we want to bridge the science and decision making? So these are like kind of a statement, a general statement that we want to merge the science, the data, the models with the decision making, and also at different levels of operations. The policy also, we have to consider the policy. We have to consider different factors and different levels of operations, but also keep in mind all of that we want to reach a sustainable way. So kind of like a long-term framework, not just thinking for now, but also thinking for the future in a sustainable way. So one key factor when we think about the decision making, it's not just a kind of, okay, I will go and I have this data, I have these models, I will build this system and then I will just put it online for the people to use it. No, I think that one key factor before making this operational, making the system operational, is to get engaged with the stakeholders. The stakeholders, I said, some examples in the case of water resources are the dam operators, the water managers, water planners, the farmers. All of these are considered a stakeholder. And the stakeholder participation is very important, and it's a kind of iterative process. We have to keep talking to the stakeholders, see what are the needs of the stakeholders. And two things we will kind of produce from talking to the stakeholders. One thing is to understand the physical system. And this, I think, it's important for the stakeholders because we build the models and maybe we understand the system, like the watershed, the Nile Basin. We understand what is going on as a researchers or scientists. But I think the stakeholders also, it's very important for them to understand the system so they can maybe tell us what they need or what, based on the system and how the system behaves, what are the needs they want to include in this decision support systems. Another factor is to understand the drivers and constraints of each stakeholder. And this, I think, this comes to the researcher, not for the stakeholder. So this, I think, important for the researcher to understand what are the driver and constraints of the stakeholder. Maybe stakeholder can say, no, I cannot use the remote sensing with this accuracy or something. I need to have the decision support system working with in situ data. So we have to make sure that like the stakeholder understands the uncertainties and if this is applicable for him or not, or for the stakeholders in general or not. So there is different approaches to do this kind of stakeholder engagement. I will not go through that, but there are many papers published. Actually, it's not a kind of like some of them are engineering papers, but if you want to read more about this kind of like, I feel like it's more like social papers or something, or they have a kind of social aspects. But I mean, one of the approaches to have this process of communication, consulting, and doing participation, partnership. So there is a different procedures here to do the stakeholder engagement. I'm showing one actually from the Organization for Economic Cooperation and Development. But you can, for sure, I mean, there's many literature on that, and you can visit and see how the stakeholder engagement can be done. So let's look at some of the examples. I mean, for the DSS, the DSS has probably three main components. One of them is the database. You should have like a database for the different data that you are going to use. And for example, in our case, when we said we are using Google Earth Engine, so we don't have to have like a database stored in our computers, but maybe we are using the satellite remote sensing that's already the data is stored on the Google servers. So this is one component. The other component is the models, and probably you have seen a lot of models, and there are different types of models. You can have like the hydrologic model, and even the hydrologic model can be a physical model. It can be like this kind of machine learning model, like Shahryar has shown us like doing the artificial neural network models to kind of forecasting the stream flow and so on, and also using it for the temperature. So models are very important. And also the third thing is the DSS user interface, which is a kind of the front end, what we will produce for the user. So the user need to have like a kind of friendly interface so he can easily use it so for making decisions. And so, I mean, an example is like having a GIS platform or something like that. So I just want to kind of emphasizing on the models because a model is kind of main component when we talk about the decision support systems. And yesterday, I remember, I think I got a question which was very important. I mean, if this model, can we believe in this model if you are calibrating the model for a certain period and then you'll be using it for the future or something? I think that was a very important question, and I was thinking yesterday, yeah, I think that's true. We although we do the validation, I know, and kind of like just to make sure that the parameters we are using is correct, but still the computer models are important. I mean, because as I said, we don't have the direct measurement. It's very hard, sometimes expensive, and it's good that we can do a prediction for the future. But we have to make sure that we are not like to kind of like love our models, because this is a kind of a comment for everyone. When anyone builds his model or her model, they will be like kind of loving the model. They will believe that this model is the best, you know. I mean, for example, I'm using the VEC model, or the variable infiltration capacity model for the Nile Basin. Sometimes, like, okay, if someone is using other model, I'll feel, no, my model is better, you know. So I like this kind of like the quotes from different scientists, they saying that all the models are wrong. So we have to believe that the models will not give us like the perfect simulation of stream flow or any other variables, but they are very useful. I mean, we can kind of making decisions from the models, but we have to know that they are wrong. Another cause is that sometimes, you know, that's what we do in the model. We try to make this things simple, but not simpler. And maybe this one of the questions also I received yesterday when they are saying, okay, did you consider like the dams in between GERD and HAD, or the evapotranspiration or something like that? I think the questions are very good, and they may be reflecting one of these quotes, which is like, we are doing these models, but we are trying to simplify some of the models, but we have to make sure that not to making it simpler. And the last one is saying that there is a simple solution, but it's wrong. So we have to believe also that the simple solution is not the correct solution, it's not the true solution. So I just want to share this to make sure that we are using the models, but we have to make sure that we know that these models are useful, but they are still like have uncertainties. So let's recap some, I mean, going back to the Nile River Basin and recap some of the challenges. Again, I said yesterday, maybe if all of you are familiar with these challenges now, that the transboundary river basin, the data availability, the increasing in the population, which will increase the demand for food, energy, the coming dams along the river, and also the climate variability. So all of these factors are challenging in the Nile River Basin, and I think it becomes important to think of having a kind of like system that advises our reservoir operation, especially this existing reservoir, how can they operate in the future? Because most of them, they are operated based on a very old operation curves. Like the highest one dam, I think it has been built in 1960s and been starting operation in 1970s or something. And maybe the rule curve or the operation curve has not been updated since that time. So when we have a new dam that's introduced to the basin, probably we will need to think, okay, how can we update or adapt the operation to these challenges? And here's the one kind of a schematic of how, if we think about the adaptive reservoir operation. So, I mean, this is like a kind of like simplifying the hydrology of any basin. It starts with the precipitation. We have some measurement for the water level. Just me get the laser pointer. So yeah, so we have the rainfall, we have the water level measurement, we have rainfall coming from the upstream. For example, in our case, it's coming from the Blue Nile or the White Nile. We have the data that we save it somewhere, database. And then what's next is important, which is the dam operation. And then since we have the dam operation, and also we have to have some kind of model or prediction system, which is here this is number 3. So in this system, it's feeding actually from the database. So we have the database storing all the data that we have, and then we feed the prediction system or the model, running the model, and then we can kind of making decisions on the operation of Reservoir. So I will be kind of focused on these two components, the making decisions, which is very, as I said, is very important, but also something else which will be informing. So after we kind of having different option or different decisions, we need to inform that, and probably informing it, how we will inform that. I think yesterday Indira was showed one example in I think it was in Pakistan. What they did is just they're informing the farmers how much water to apply for irrigation on it in a text message. So they did the system IAS or for Pakistan, and it was working very well. So we have to think about these two components, making decisions, and also how to kind of informing or delivering the decisions. So for the NiBRAS, as I said, the main vision is to build a satellite-based decision support system for advising reservoir operation. And here's the interface of the Reservoir if you go to this website. But as I said, it's just a kind of a beta version. It's not the final version. So, but you can kind of go through this link and see how it works. And I will show you like a kind of live demo how it works. So the NiBRAS has the mission of like kind of 4 missions. So one of them is to provide a real-time monitoring or forecasting. So every day, if you go in the NiBRAS, you can go, for example, at Khartoum station, see how much stream flow is coming here, or go to the highest one dam and see what is the water level at highest one dam, what is the storage at highest one dam, also what is the release from highest one dam, and then this is not included yet, is doing a scenario assessment. As I showed yesterday in the different scenarios I tested for the operation of highest one dam based on the GERD feeling, or the scenarios of maybe the stress in the downstream, some kind of this playing with different factors to test different scenarios. And then also you will have the functionality to analyze the data, download the data, and then you can do your own processing or post-processing on your computers. And as I said, one important thing is doing an informing decision, maybe through a text message or maybe on social media as well. We can build like a social media account like Twitter or something, and then like kind of tweeting over there what is going on, what should they do, because maybe people now are following the social media better than like maybe like the normal text. So what is the components of the system? So any system in general, when we try to build it, as I said, we have the database, we have the models, and we have the interface. I'll be here showing like these 2 main components, and we call it for any website. We have the back end and the front end. So the back end is what is going in the back, but you cannot see that. Like the models are running in the back. The satellite remote sensing are kind of like saving these observations into maybe the Google Earth Engine server, Google Earth Engine, or the Google servers. So all of this is kind of happening in the back end, but then the user is only showing what is in the front end, like showing maps, producing some of the real-time monitoring of the operation of reservoirs, or also playing with different scenarios. So this is what's happening in the front end. And I always actually kind of like, this is like kind of like similar if you go to eat somewhere, you know, and then you first check the menu, and then you select something, and then you will receive the meal later, you know, on a plate, and then you will start eating this. So this is a kind of like, you will only see the meal that's prepared for you. So this is the front end. You only kind of like, you see the meal and you're eating. This is the kind of the front end. But actually, there's a lot of things happening in the kitchen. People are preparing the food for you. So this is what is happening in the kitchen. This is the back end. So this is how I think about it, the back end. So that's what is happening in the kitchen, which sometimes is very important, you know, because if they are not cooking the meal well, it will not test well. So the front end might be like, the maps will be kind of corrupted or something. So this, I think, a kind of like how, if you want to think what is the back end and the front end. And for sure, you know, the front end can look very nice. You know, I can do a very nice website, but actually it doesn't make any sense in terms of the numbers. You know, I can like show you like very nice maps, and it looks very nice, but I mean, the numbers doesn't make any sense. So that's actually like the meal. It looks very good, but actually when you test it, it's not good, you know? So you just can't think about it in this way. So I will skip this. I showed that yesterday. So in the NiBRAS system, I'm using the VEC model. So I mean the VEC model again. I mean I'm not sure if I showed this or not yesterday, but it has been developed a long time ago, 1994, and it's maintained here in the University of Washington by another research group. But I mean you can visit this paper and then and I mean if you want to read more about how this model is working. Again, we are using here satellites, so we're using iMerge for the precipitation, and we use a MODIS. And maybe some of you might ask, why did you use an iMerge? And we're using chirps. Actually, yesterday I showed the chirps. We are using iMerge for today. The reason for that, because iMerge is a kind of a near real time. It's available like very. Chirps, there is a kind of a delay. I think it's might be one day or something. I'm not sure what is the delay in the chirps, but it will not help in getting like a kind of a near real time observation. So we cannot monitor the reservoir at a near real time. But we can include in the system as well, and then we can, I mean, say that there is a delay in the reservoir operation, especially if we care about maybe the reservoir operation in terms of like maybe weekly or monthly operations. So again, this is that I showed yesterday for the calibration. So this is a model that's doing in the back end. I just want to make sure that we are cooking the meal well. So this is the calibration and validation that I showed yesterday for the back end. Again, this is the back end again. So what we use in the back end for model the reservoir, we use this kind of water balance approach. So we use this for the highest one dam, and the system now is working for highest one dam. So we will extend this for the rest of the reservoirs later, but for now, I think it's working for highest one dam. Still in the back end, also we can use still the same model, the VEC model, and also that this water balance model to kind of also testing different scenarios for GERD filling and operation. So I think also you have seen most of this picture yesterday, but here is also the calibration of the model at Dean Station. Dean Station is located right at the GERD. I think it's the boundary between Sudan and Ethiopia. So the model is performing also very well here. We also use a satellite, the same approach I shared with you yesterday in the Google Earth Engine to derive the area elevation curve for the GERD. And I will be using this actually to monitor the GERD filling tool. So for the tool of monitoring GERD filling. So let's go to the front end, which I think is a very important component as well, because sometimes, you know, I said like we can do a very nice interface, but the back end like is not good. But still, it's important also to see the meal looks good. You know, we want to kind of like impress the people when they see the interface, and make it also easy for them to use. You know, we have to make sure that not everyone will be using the system. He's like an engineer or he's a scientist. It might be like just like, you know, kind of a common person, you know. If he's a farmer or something, he might not be, probably like he knows that like there is a satellite, or maybe he doesn't care. I mean, if there is like Google Earth Engine running in the back end or something, he just needs something that's very simple that though he can use it to make decisions. So in general, this is a framework, and this is actually developed by Nishan, and he has this paper. If you want to read it, it's a very comprehensive paper. I like this paper that he actually explained exactly how to build this kind of systems. And as you see here, I mean, I'll not go into much details, but there is actually two things going on. So you want to kind of like develop a website. So this is actually for some of the people who are interested in computer and web development. You can sorry for that. Yeah, for people who are interested in the web development, you will need like kind of three different sorry for that. Yeah, you will need kind of three different programming languages, or kind of programming on three different platforms. One of them is HTML, which you write your main script, and then if you want to make kind of styling or for the font or something, we use something called CSS. And then also the JavaScript, if you have like a kind of, you want to insert a button or something like that. So it's a kind of, people who are interested in a computer, this might be helpful for them. But when we put a map or kind of like these global maps that you will see, or you will see for the Nile River or something, we use something called the Google Map API. So Google actually is making this Google Maps available as an API, and you can use it actually to kind of import it into your system. So every time you open the system, you will see this Google Map. For sure, you need the web templates. There is some kind of templates, which is, some of them are free, some of them you have to pay. So you don't have to build the design of the website from scratch. There is some templates online which is available, and it's free as well. You can use it, and you just make some changes. I think I mentioned this. Yeah, one more thing is how to produce these kind of charts that we will see, like time series or something. There is some tools, like one of them is called High Charts. You also can import this into your script, and then you will see this kind of different charts. So I mean, this is different components that you can use to build this kind of operational systems. So again, the NiBRAS, the front end will have different tools. As I said, one of them is the real-time monitoring, and this one it's working now for the highest one dam and also for the Khartoum station. Then the scenario assessment tool, this is still in progress. Also, I will include the forecast-based adaptive reservoir operation, what I call the FARO. This FARO approach will kind of like informing the operation based on forecasting some of the stream flow in the future, or maybe also forecasting how the GERD will be operating in the future, and then informing other reservoirs how to operate. And then the monitoring reservoir initial impoundment, or MRI2, I will show very quickly. I think this tool is still in progress as well, but I will show you how it will work in the future. So here's some pictures. I think I might go to the website to show it to you. So let me change the screen. Yeah, it's here. Okay, I will, yes, need to stop sharing this. And then this. So I think you should now see my screen, right? The NiBRAS system. Yeah, so I'm showing the NiBRAS system now. So here's the system. So when you open the system, you see the NiBRAS system. It has different pages. It has the home, about, map visualization. In the map visualization, you can see like the outputs of the VEC model, spatial map. These two components, the FARO, the forecasting one, and the scenario assessment is not working yet. I also added like this section for news, but maybe in the future I have to update it. It's kind of like giving some of the articles which is published already online on the Nile River Basin or something. But let's get back to the home. So the home page here is you can, like you see, this is the Google map that I imported using the Google Earth. Sorry, the Google Maps. So we import this using the API of Google Maps, and then you can see also you can import the shape files and the different boundaries of the sub-basins in the Nile River Basin. You can also turn off the layers. You know, you have this layer for the sub-basin. You have you can turn it off if you want. You have also the stream flow. I'm also showing you this database for the existing and future dams. So the green one is the existing dams, and the red one is the future dam. So this is the kind of like the database which is produced by Zorf et al. In I think 2015 about some of the future dams. So you can also turn off or turn on and off these dams. So the legend also showing again the existing future dams. But I think this NiBRAS watch is what actually the NiBRAS is kind of tracking or monitoring. So for example here, this is the GERD. I think the GERD is not working yet, but I have for the Khartoum, for example, if you go, yeah, I think my screen is a little small to show everything, but let's go down here. Yeah. So you can see here, this is actually the VEC model. After running the VEC model, it will give you an idea about what is the stream flow in Khartoum every day. And you can see here, September 15, we are today, I think September 23rd. I think there is a kind of a lag in my model now. Maybe it's a difference of the time between the east and west, but it can say, I think it can show up to yesterday, September 2022, and showing the stream flow here. It's like 18,500 something meter cube per second. And you can see this is, I think, the peak flow when it happens in Khartoum, maybe. Yeah, I mean, maybe people in Sudan can give us more better information about if this is actually that's when the flood happened or not in Sudan. But that's how it, you can actually see the stream flow every day, how much stream flow is coming into at the Khartoum station. So this is one thing. You can also go to, so this is a kind of the component, the model component, but if you want also to kind of see how the reservoir is operating, so it will show you three things: the inflow. So this is the inflow from the reservoir based on the VEC model, the storage change. Storage changes will be actually based on the reservoir water balance, and the outflow is again based on the, I'm sorry, the storage change is based on the satellite using the Landsat or using the altimeter, but then the outflow will be used using the water balance. So here is the inflow also to highest one dam. So you can see also the highest one dam, how much water is coming in up to yesterday. Again, you can check the storage change. Here I'm showing for two different approaches. One of them is Landsat. The idea, you can turn off and turn on and see how much storage change is in the highest one dam lake or Lake Nasser. And the idea to show the two sensors, you can see there is a big difference. So, and as we mentioned in all our talks, that there are a lot of uncertainties in the satellite remote sensing. So it's good sometimes to kind of to show the multi-sensor or different sensors, so you get an idea about what is the range of uncertainty that's covered by different sensors. And you can also see the outflow as well. So this is the different, different components of this interface, but we also can go to the map visualization. I'm still actually working on it, but I believe for the Blue Nile, it's working. So for the Blue Nile, if you go to the Blue Nile, for example, and then this is the output from the VEC model. So we can produce the precipitation, the runoff, the base flow, evaporation, and soil moisture. So let's for example, pick like maybe precipitation or something. And maybe let's say, what is the precipitation maybe 2 days ago? I think here there is a lag or something. Let's check if it will give us. So it's good, it's working. So it's giving us a precipitation maybe like in September 20, maybe if we check maybe 21, it's working as well. So maybe this is the last Monday, how much is the precipitation over the Blue Nile. So here's the legend. So it's maybe around this dark blue area is around maybe 9 or something millimeter per day. You can also show different like soil moisture as well. I mean, if you just click plot and then you'll show you that soil moisture over the Blue Nile. So we will be adding more and more components to this system, but I think that's what the system can do for now. But I think the future will be to, as I said, adding more components like the weather forecasting or the scenario assessment and so on, and also adding the other sub-basins like water coming from the White Nile. Other thing as well we will be doing is to what we are showing here is only for the hydrologic model, but I've also developed the artificial neural network model for the Nile Basin. So I'll be showing this, so kind of like giving the user flexibility to choose if he's interested in using the machine learning approaches versus using actually a physical model like the VEC model. So let me go back to the slides and. Yeah, so going back to the slide, I think I've showed the tool for the real-time monitoring, the hydrology of the Blue Nile Basin, like precipitation, evaporation, all of this. So let's go to the second tool. So I think we are in time. Okay. So the second tool is to monitor the reservoir initial impoundment. And you know, we have seen a lot of dams that's coming into the Nile Basin, like maybe in the future, like the GERD or other nations as well. But in this tool, I will be showing it for the GERD. So I developed this like in the summer for the GERD. And let me go back to maybe the website. So here is a tool. So when you go to the website, it's called MRI2. It's monitoring reservoir initial impoundment, and it will have two different tools. So three different tools. One of them is a real-time, again, monitor the real-time. The upstream hydrology, it will show you what is the upstream hydrology, like the upper Blue Nile, how much precipitation. Again, this will be the VEC model outputs. And then maybe the forecasting of the future. So again, if we have information about the future, how much water is, how much precipitation will be there, and how much stream flow, then we can maybe kind of forecasting the filling in the future. So you can go here, read more about the tool, and also I have some kind of introduction for the Grand Ethiopian Dam. This is a cross section of the Grand Ethiopian Dam, which maybe, I mean, I put it here because the levels are very important. It's, if you want to monitor the feeling of the dam. Also, I mean, this is a storyline. Probably I showed you this yesterday in my presentation. So I mean, if you want to get an idea about the GERD. So now it's working for GERD. If you go to the tool, let's kind of like, let's check this tool, and then you will have a different satellite missions. So you can check between Landsat, Sentinel-2 and Sentinel-1. So this is our actually different missions. So Landsat is, you probably know, most of you know the Landsat, but this, it's a mission between USGS and NASA, and I think maybe other agencies as well. But the Sentinel actually are, the Sentinels are the missions by the European Space Agency, which is yeah, sorry for that. Yeah, European Space Agency, ESA. So they have also their own missions for like this spectral images. So it's a kind of like the same like Landsat, working the same, but it's better, higher resolution. So Sentinel-2 is actually, I believe it's 10 meters, and Landsat is 30 meters. So it's a kind of better resolution. So let's, for example, look at the GERD. So the GERD is here. So I did this for actually for Sentinel-2. So for Sentinel-2, if you kind of, for example, you want to check how much water is stored now at the level of 550, for example, okay? And because the tool actually is not running for now, I did this tool in July, and it was running during July. So let's check, for example, 15 of July, was the dam filling at that time or not? So if you click submit, then you will see here. So what is showing here actually is, so this is the dam. This is actually a kind of the boundary of the shape file of the area at this elevation. So if you remember the area elevation curve that we tried to derive, so this is, if the dam was completely filled, all of this gray area should be filled. So, but what we are seeing now, it's just, I think it's a normal stream. So it's not filling at this level. What if we try like a less level, like 525? So at 525, again, this is actually the gray is actually what should be, if it's entirely filled, it should be filled all of this gray area, but it's only, again, filling only this stream. So it seems also it's not filling. So I think that's maybe important if you want to kind of tracking if the GERD is being filled or not. You can choose different elevations and see if it reaches this elevation or not. For example, I think the 586 is a kind of the operational level. Maybe it's 590 or something around that. So if you go to 590, you see it should be filling all of this gray area, but it's for sure it's not filling yet. So it's only showing the stream. So this is actually how this will be. You can use this, and I will update this to the current dates. I did this in the summer in July, but I think in the future you will be, you can see more and more sensors that you can use it, and also you'll probably see it to the most recent date. So you should be able, maybe in the future, if you go to the same day, like today or something, you will be able to see that. I also have provided the user manual here if you want to go and read more about that, how's the back end, what is the back end, and what is the front end. So it's very short. I will also try to extend it to explain more about that. So I think this is the MRI tool and the NiBRAS tool. I'll stop sharing and going back to the presentation. So I think it's might be you have seen all of this. Yeah, something I think maybe I didn't show you this, but it's the same like the NiBRAS. If you click at the dam, maybe it's worth going back and showing you this, because I think there's something here nice to show you. So I think there's something nice as well. If you click on the dam, you will see again the GERD inflow, how much water is coming into the GERD, the impounding elevation. And I think that's will be interesting. So you can see actually using, but again, this is using satellite. So there's sometimes there's uncertainty or some outliers we have to consider, but it's giving you a kind of the trend. You see here, these are the dates from 2016 up to 2020. So you can see what is the trend in the elevation of the GERD. So, and probably, I mean, this was during the construction, and maybe this is the kind of the normal elevation during the rainy season in the summer or something. And this is in 2018, and this is 2019. So probably it's not extended here. I mean, at the last day with maybe in 2020, it's in June or something. But I think like you can see that it's peaking in 2019, 2018, the same. When I mean, I think that at that time the dam was not filled yet. So I think that's good also and important. Maybe if you wanna kind of every year maybe tracking how this is compared to the previous year before the filling, how the elevation is compared to the previous year before the filling. So I will stop and going back to the slides. So now I'll move to kind of scaling this up to global applications. I think I will let Nishan talk more about that, but just very quickly, I will show you some of the other operational systems, and some of them are working the same way like NiBRAS doing this reservoir operation, and he will show also his RAD tool for Africa, Southeast Asia, and South America. This is most of the developing nations, and this is a paper actually also, if you want to kind of visit this paper on that Nishan published for the RAD tool. Again, the RAD tool, Nishan will show you this, how to do it. It's here for Lake Victoria, the Oin Falls. Yeah, so I think Nishan will explore more of this, our research group systems. This website, all the time you are welcome to visit and check most of the tools we have. I think I will stop here. Nishan will share his slides, but before just moving to the screen to Nishan, I would like to acknowledge most of the funding agencies and people who provide help and data as well. You know, University of Washington, NASA, Alexandria University, USAID, and I mean, some of the systems that Nishan will be showing, it's also was developed with the cooperation with the Bangladesh Water Development Board. So I would like to acknowledge all of these organizations. So I'll stop here, and I mean, I will let Nishan share his screen. Maybe he will kind of doing a live demo for different systems. And thanks very much for listening, and maybe let's move to Nishan.
Hello, everyone. Thanks for Hisham for the nice presentation and explaining all the backend things and front-end steps. Yeah, so I'm going to share my screen. Hope everyone can see my screen, right? Hisham, can you see?
Yes, Nishan. Yeah, we can see. Yeah, right.
Yeah, so these are different systems that has been developed by our group, like the number of tools that we are working on, and most of the important that all of these tools has been developed using remote sensing and Earth observation data sets, like satellite data sets. So yeah, so I thought that it might be useful for you guys to see like what we have done so far for the greater good of human, for the like underprivileged communities. So yeah. First, I'm going to show that reservoir assessment tool. Covered around 1,600 reservoirs from Africa and Southeast Asia. So yeah, let's see. I already have opened the window. So yeah, so the front of the tool. So here, what we are doing, like the system is going to the like different server, download different data sets, and like it's using Google Earth Engine to process the like satellite images to get reservoir surface area, and also using hydrological models such as variable infiltration capacity model that was explained to get the inflow into these reservoirs. So example is here for I think it's on the it's in the east West Africa. So if you click here, like so, I can show. So if you hover on any of these icons, these are actually the reservoir locations. If you hover on any of the icons, you will see like the reservoir name Grand ID. Grand ID means like there is a database developed for the global reservoirs. They provided the ID for different reservoirs around the world, and the name of the river, you will get information. So if you click on any of these locations, you will see the AEC, that means area elevation curve of that particular reservoirs. You can see here, this is the area elevation relationship of that reservoir, which is developed from by using the radar transmission DEM. And also the mark here, it is the dam crest level. That means like this is the of the dam crest. And here is the surface area of that particular reservoir. If you see, so this reservoir surface area has been processed using Landsat 8. And here we use the DWI method. Actually, there are several methods. As I was talking about the so there are the different methods. For example, normalized difference, modified normalized difference, vortex, or dynamic surface water. There are several methods, but here for the simplification, we used NDWI method to prepare the images into water and non-water area, and just took the water area to like how to extract from those satellite images. And also here there is Landsat 5 data. So Landsat 5 is sometimes like was not processing correctly. So we are focusing more on land because this is the most recent satellite missions that, and also it is running right now. So we can get the data from this Landsat 8. And here we include that particular reservoirs, and this inflow is coming from variable infiltration capacity model, which is the hierarchical model that we are running in a globally to get the inflow in each of these locations. So we have this surface area and so we have storage sense that is actually area elevation relationship and surface area time series to like calculate this distance behind the dam or the reservoir. And finally, we also have the flow from that reservoir. So we are using simple mass balance. We are doing have this inflow amount, we have storage sense, and we know the evaporation from that reservoir surface. Then we are just adding the outflow. Also, I have one more thing, that is operating rule curve. That means like we're taking into consideration different like the storage data of the like historical storage data of last few years to calculate the storage sense pattern. So here in the y-axis you see S by S max. That means like specific or like the storage live storage with like by considering the maximum storage capacity of that reservoir. So this is actually not the actual rule curve that dam operators will follow, but this is the rule curve that we derived using the long-term historical data. So we thought that this might also be very useful for like international community, or when there is international rivers, so you don't have access to the actual rule curve of any reservoirs, so you can get an idea from this tool. We have the same parameters for all of these locations. For example, if I go to the highest one dam, you will see that this is the elevation curve, and this is the surface area time series of that reservoir. I actually showed this time series of water extent area during my first presentation. And also you will see the storage.
Yeah, I think that's very interesting. I mean, if you go back to the maybe the inflow or the surface area for highest one dam, it's showing that there's a I think significant increase in the trend, which probably people in Egypt now they know that there is a storage level in highest one dam is increasing a lot, and maybe if we have people from Egypt, they know about that, and I don't know if we have anyone from the Ministry of Irrigation, but I think they are trying now to kind of maybe releasing some of the water to the downstream, and yeah, I think that's good that we are seeing the same from the satellite as well. So thanks, Nishan. It seems like the system is working.
What was the underlying reason for this like sudden increase in the surface area extent of a highest one dam? Is it related to guard operation?
I think it's no. What happened? I think this year there is a unexpected rainfall happening in the upstream in the,
Okay.
the Blue Nile, and actually that's why, for the same reason, there is a flooding that happened in Sudan a couple of weeks ago. So there is an increase, and yeah, I'm not sure if Egypt is storing water or not for for the future, but but
Like
one reason
surprised. Yeah.
one reason is probably for the because of the unexpected. They said it's like maybe 100-year return period or something, precipitation that's happened in the in
Or
Sudan or oh sorry, in Ethiopia, and then stream flow is too much. So yeah, but one thing I noted that it's not only 2020, it's 2019 and 2018. It's the trend is going up.
yeah.
So so
Yeah, I
maybe
was thinking that there any political issue between like upstream and downstream countries.
yeah,
That's they're
yeah,
spending more
I'm
and more water. Yeah, I'm not sure.
yeah,
I
not
to see the results.
yeah, it's okay. I mean, it's fine
Yeah.
anyway that remote sensing is showing what's happening in reality. So that's good. But let's yeah, go ahead, man. So
Yeah, and also like you will get more reservoirs in Southeast Asia region as well. So I'm not individual dams or reservoirs in particular. Pretty much similar for all of the reservoirs that we are getting inflow from hydrological model. We are generating surface area time series from by processing satellite imagery through Google Earth Engine or cloud computing, and also and we are like processing rest of the data to visualize the reservoir monitoring system. And I feel like this will be really useful for international reservoir or international rivers where you don't have access data to the upstream area, or you don't have access to like a remote area of any river basins. You can get an idea using that satellite data. This is actually the power of satellite remote sensing data, that it is unbiased and you can get data from anywhere of the world if you want. Yeah, so we have a few more systems that has been operational at our end. For example, this is IDEA, that's Intelligent Dam Decision and Assessment. This is actually from Shadier's research. I'm not going too much details of these systems, but I want to show one more thing to you guys. So this is actually the flash flood forecasting and early warning system. This is actually for a particular region, developed for a particular region, which is in the northeastern region of Bangladesh. So there flash flood occurs every year, and a huge damage to crops and properties happens due to the flash flood. I think if we define the flash flood, that like it usually happens when like there is like steep slope of the terrain upstream to the river basin that on like flow occurs immediately after precipitation event. So here in this region, this is actually we usually call food basket of whole country. The country is Bangladesh here. So, but due to the flash flood, sometimes like a huge damage occurs to the crops. So we thought that can we use like satellite-based, remote sensing-based data to forecast the flood in that area? Because we know that like traditional flood forecasting is already have proven track of like several publications, and also like there are number of systems available in the whole world flood. But it is a new era that we can actually do the flash flood forecasting using the satellite remote. So here, what we are doing, like we are using global forecasting system data that's actually available in National Oceanographic and Atmospheric Administration of USA. So they actually made that data available for the global scale. So this data can be applicable in any of the world. So they have the 15-day forecast precipitation. So we are using that precipitation, and then we are using a hydrological model for the upstream area of that study region. So here you can see the whole basin. So this is orange colored area and the shaded area. So this upstream area, for example, this is Meghalaya. So one interesting thing about this Meghalaya is that it is receiving the world's highest amount of precipitation every year. And this is like in the hilly area. So all the flow from this area is coming downstream to this region where like there are several crops are being in production every year from Bangladesh side. So yeah, so we are running that SWOT hydrological model to get the inflow at these blue locations, and then we are using that inflow to force into a hydrodynamic model. So here we are using NiBRAS model to generate to simulate it in two-dimensional scale. So what it is taking into consideration, like the upstream flow from this hilly region, and then it is also considering the precipitation over the study area as well as the terrain or DEM. So it is considering all of these things to generate the flood forecast with the flood inundation map for the upcoming days. For example, here it is shown. This is for 6-hour lead time. If you go to 3-day lead time, this is like the flood inundation, and if you click on view, so it will come because it's like a very high resolution. This 30-meter by 30-meter resolution data. That's why it takes some time to load. So this is the actual flood inundation map that will happen after 3 days. So here, for any particular location, if you click, you will see the water level forecast at that location. So this is actually the water level forecast. This is a particular station. So the green line here, this is the nowcast, and if you go to the blue line, so this is actually the forecast water level for the next 3 days in that particular location. Also, we have the inflow data for this location. So the inflow data. So you can see the date is 23. That means like today's date, and these are like the upcoming days. And here you can see that there's like actually there's two different types of forecast data here. One is like GFS actual data that I was saying that we usually download this data from National Oceanographic and Atmospheric Administration NOAA server. And so we also have one more forecast precipitation product, which we are calling WF downscale precipitation. That means like we are running weather research and forecast model in order to downscale the actual forecast precipitation of that region, because we know that when there is a global product, there's usually there's some uncertainty and at a very regional or local scale. So this is the model that we usually use to downscale the precipitation in order to make it more useful for local or regional scale. So yeah, so here you can see that those particular forecast product. One is WR downscaling this forecast. That means like we are taking that GFS forecast and then we are downscaling that to make it more useful in that particular region. Also, we have one more forecast product here. This is EMW. That means like European forecast data. We are getting it from European Union. So this is a forecast based on those two different products. And also, if you go to like any other precipitation product, precipitation product, and if you see a particular like lead time, you'll see the map. Yeah, will come. So yeah. So yeah, that's it. So this is a particular example that we are applying the remote satellite remote sensing data as a very regional and very local specific. So this the data sets that we have been using in this particular study, and also the models that we are using. So data sets are all available at a global scale, and the models are open source and freely available. So this concept can be applicable to anywhere in the world where usually flash flood occurs, or even if there is no flash flood, you can also use this data for a particular local or regional scale in order to forecast the traditional flood, from this satellite remote sensing data. Yeah, and also we have a few more examples here. I think I will paste this link into the chat box. So if you guys want to text it, you can also.
Nishan, your voice is was cutting a little bit. You said you stop here, or you were showing something?
No, like I was saying that like I can also copy this link into the chat box. So
okay, I have it in the presentation as well. So as I said, I mean I have this link, and you can copy in the chat box as well. So we have this link. You can visit any of these operation systems, and I think it's very good also to see this forecasting component, because it might be useful for the Nile Basin as well. You know, Khartoum in Sudan in general, they just received this flooding last couple of weeks ago, and I think using maybe this forecasting information is very good. Nishan showed for a flash flood, which is a very short time scale, but there is other products also at longer time scale. Then I'm using for the operational fast one, I'm using the NMME. It's a North American multimodal ensample. So anyway, it's kind of like giving you the precipitation for the future at a monthly scale. So you can know the precipitation maybe for 12-month lead time or 11-month lead time, something like that. So you can also, if you are interested in the long-term forecasting, there's other products for that. And I think that's I think it's very important if you want to apply this maybe in other regions. In Egypt as well, I know there is a forecast. There is a flooding that sometimes happen in the northern Egypt around Alexandria or something like that. So this maybe forecasting product can be helpful or useful to predict the forecasting and predict the flooding, and maybe kind of like taking some measures before the flood happens. I think, Nishan, do you have any other?
Yeah, I think that's it. Like, we have one more thing that I can share. Like, this is another example that we are using, that multiple satellite mission in order to improve the accuracy of satellite data as well. So this is actually the Basin 3 data-based water height visualizer. So here, what you will get, like in every of these locations, there is more than 150 locations in Southeast Asia region. So here what we are doing, like we are deriving the altimeter. I think Hisham talked about altimeter in an earlier presentation, right, Hisham?
Yes, I talked about altimeter. You remember even in the Google Earth Engine exercise when you were kind of getting the Lake Nasser water level from the hydro web. So this hydro web was based also on the altimeter. So yeah.
So here we are doing that altimeter based height of the particular locations along the river. So, but fascinating here is that, like here, we have shown that if we use multiple satellites instead of one single satellite during the decision making or information derivation from the satellite data, yeah, obviously sometimes it makes it more accurate. For example, here, this is the altimeter height at a particular location along the Ganges River. But if you click on the dynamic river width base, so you can see that this is actually more following the more accurate trend than the actual altimeter height. So why it is getting that improvement? So what we are doing, like we are using additional satellite mission. For example, here we use Sentinel-1 to first derive the actual river width, and then we are like calculating the river height from that. Based on that Sentinel-1 based river width, and we saw that it was like getting improvement from the actual observation by using only the altimeter height or by using the only altimeter satellite. So the take-home message from this tool is that, yeah, sometimes satellite produces information that is not that much useful for us, but yeah, there are multiple satellites are revolving around Earth, and we can use the like optimized selection of satellites in order to make a better decision. And yeah, that way we can like get improved estimation of water resources parameters or anything that will be more valuable for our purpose. Yeah, that's
yeah. Thanks, Nishan. Yeah, that's very helpful. And actually, it's we have other systems. You're very welcome to. I mean, in the group to visit. And with this one actually thing we didn't maybe touch during the workshop is using remote sensing for sediment transport as well. So we have another system if you are interested in sediment transport or to monitor the sediment. We have another system here that's actually. I think the system is available in both, like using the Google Earth Engine, and also it's available as a website like the NiBRAS or RAT. So it's available both like an Google Earth Engine application and also available as a website. So it's called BROS. I think it was developed for Bangladesh as well as a remote sensing of suspended sediment. So you can use this as well, and you can see I think we didn't touch that. I mean, we didn't have enough time to cover all the applications for remote sensing, but this is actually one. It's very interesting. It has been developed by Claire Beveridge, which she graduated already. She's like she graduated already. So I think you can visit this. It's the system, and it's working by both, like if you want to use a regression model maybe, or machine learning model like artificial neural network. And yeah, that's I think also interesting thing if you want to learn more about this. So I think we should stop here because we're kind of like a little running out of time. So let's take questions. If you have any questions about the systems, or if you have any questions, feel free to ask questions before we go for break, and then we have our final session. So please, if you have any questions, type in the chat box or just raise your hand, unmute yourself, and ask us any questions you have. Yeah, we'll be happy to take your questions.
Yeah, I think someone, Ahmed Ila.
Dr. Ahmed, yeah. Dr. Ahmed, you can unmute yourself. Yeah, go ahead.
Thanks a lot for your great presentation. Actually, these portals are very efficient, actually. So my only question about the the areas. So the oldest areas you can get for Lake Nasser, surface area of Lake Nasser. So how old do you get for it? The oldest area using remote sensing?
So
because I saw some gaps between 1984 till maybe 2000 or so.
You mean in the NiBRAS system, or in the RAD tool? Because in my NiBRAS system, I think I'm only showing the most recent. Yeah, I think.
No, in RAD tool, yes.
Or RAD tool, okay. Nishan, you can. You can answer the question, Nishan, if you want. I think you're muted, Nishan, I think.
Yeah, hello. Yeah, for the Lake Nasser, I think you can get data since 1984. But yeah, for Landsat 5 processing, I saw that there are some gaps sometimes in water resource or water surface area or water surface area extent. So in that case, I need to explore. But as for now, I can say that you will get data since 1984 Mars.
Yes. So why is that?
Yeah, actually, there's some that there are some quality control of remote sensing data. For example, for Landsat 1, we usually call Landsat 1 L1T1 data. We say it L1T1. That means like those imageries have passed the quality control. And there are some data that we call L1T2. That means they have not passed the quality control. So that's why sometimes there is gap. Even for now, like if you see 2017 or 2016, sometimes you will see that you don't have the available satellite data over your lake or anywhere you are interested because of that quality control issue. So sometimes they do not push the data which they feel like it might not be very accurate to push this particular scene in the user data sets or for public access. Yeah, that's why sometimes there is gap in the surface area extent of the reservoir.
Okay, thanks.
Yeah.
Thanks very much, Dr. Ahmed. Yeah, that's a good question. Sure. I know people in Egypt will all the time will visit. I know Highest Dam, and they will pick everything there. So thanks very much, for checking this. Let's take any more questions before we go for break. We can take one more question if anyone has more questions on the systems or in general. So Muhammad Ahmed is asking for, can we make the data to act at a site specific? So do you mean like, so now it's working for each dam individually? Probably you mean about the reservoir operation, or
Muhammad, I think he can unmute himself and ask the question.
You can, yeah, you can unmute yourself. If you don't have the mic, you can just, can you clarify a little bit, like can we make the data I mean, which data you mean, and just like, if you mean the site-specific, like the reservoir or the flash flood system. So, I mean, if I understand the question correctly, I think maybe you mean like if you go to any place, like click at any site, and then it will generate the data. I think in the case of reservoir, no, it's only working for reservoirs, right, Nishan?
Yeah, not everywhere in the world.
Yeah, it's not
But
everywhere because
yeah,
that's
one
how.
more answer to your question is that if we can assume that, yeah, you want to extract data that we are using in these systems for your particular site, yeah, that is true, because all of these data sets are global. So you can extract this data for any of the locations that you are interested. For example, the forecast precipitation data that we are using in flash flood system, or the satellite images data that we are using in this global reservoir assessment tool, or whatever it is, like all these data sets are global. So you can extract those data sets for any specific site that you are interested.
Yeah, I hope Mohammed, this answered your question. I know you're saying that the microphone is not working, which no problem. I think also you can, if this is not the answer, you can anytime just email us, and we can try to maybe clarify more about that. Email me or Nishan or both of us. And Nishan actually is our system administrator, so that's why he has to show us this all of this work. I mean, Nishan has done a lot in developing and this kind of system. So I mean, I think all the credit should go to Nishan and the rest of the group as well. I mean, Shariar also has developed a lot of tools as well, and I mean, Claire and Indira now is also developing a new system. So yeah, feel free to contact any of us anytime. We'll be happy to help and answer your questions. And if you have any idea about systems or something, we can help. I mean, guiding, like giving you guidance how to build this kind of systems or something. And as I mentioned, the paper that Nishan like published, even for myself, I learned from this paper and the development of the systems and what is the steps and so on. So I think we kind of stop here. I think we are running out of time a little bit. So there is one question. I'm sorry. There is one question I think from we have two more questions. So we can extend it, no problem, because actually the next session maybe we can start at 10:45. This is the last session, and actually it's an important session because we want to share some information, it's important details and information with you, and also want to show you a kind of initiative that I started this year, and I want to just a kind of sharing it with you. So if you are interested to participate in it or not, so please wait for the last session. But let's take two more questions from Taragan and Ilham. So please, Taragan, you can unmute yourself and ask the question. Yeah, go ahead.
Okay, thank you. I have a question for Hisham.
Yeah.
For the advisory system you developed on Nile River Basin.
Yes.
Is that possible to adapt for the Blue Nile, which is under construction of the Kerch at the upstream of the Nile Basin? Can we consider it is adaptable, the system?
Yeah. So yeah, I think it's actually now mostly working for the Blue Nile. So and the same way we are doing it for High Aswan Dam, we are planning to doing for the GERD. But the GERD, it has two phases. So it's first it will be filling and then operating. And I'm planning to include everything for the GERD because we developed the model, like kind of the operational model for the GERD and also the filling model of the GERD. So I'll be doing that for the GERD and maybe other dams like Reservoirs and Sinar, and maybe making it more comprehensive. I know now it's a kind of very limited with that it's giving only for Khartoum and then for High Aswan Dam, but yeah, I'm planning to extend this in the future for the rest of the dams and probably for the Blue Nile as well. Yeah. So I hope this answers your question, Targan.
Because if it is extended for the GERD for the downstream countries.
Yeah, I agree with you. I mean, once it's be applicable for the GERD, then it will show more impact for the downstream. And that's, I think it will come in the scenario assessment tool that I'm trying to develop. So I'm trying to develop this tool so the user can just kind of, say, okay, I will assume the GERD will fill in 3 years or 4 years, and then let's see how long it will take to I'm sorry, how this will impact the high aswan dam or any dam in the downstream. So this, I think, will come into the scenario assessment tool. Okay, Targan. Okay, thank you, Targan, for your question. Yeah, I really appreciate it. So we have a question in the chat box, and we have, but let's take first Ilham, because you, Ilham, you can ask, unmute yourself and ask a question, and then we will have another question.
Yeah, right.
Hello, everyone. First of all, I will thank Mr. Nishan and Hisham Eldardiry for this informative presentations and huge information. So I would ask about you said that there is application specialist in sediment movement.
Hello.
I think you are muted. Ilham, you are muted. Oh yeah. Can you just say again? Can you say again? Sorry, when you said about the sediment, can you say it again?
Yes, I need this brief information about this application for sediment movement. We need this a lot after this flooding period in Sudan. All of you know this. So if you give me brief information about this application.
Okay, so
and how can I?
Yeah, so okay, thanks, Ilham. Yeah, I think that's a very good question. Actually, as a sediment, I didn't do that much research on sediment in my work, but okay, I think Nishan, you stop sharing. I will share my screen for the website, and then maybe.
Okay, yeah.
Now let me just pull up the link very quickly. Yeah, I think you can see now the screen, right? The systems, right? So this system actually was developed for Bangladesh. It's developed by Claire Beveridge. She just graduated the PhD last month. So she did the work. She did the work in Bangladesh. Yes.
I think it is better to show the FASU system rather than this one. Like sometimes Google does not work properly. Yeah.
Okay, this one, right?
Yeah.
Okay. So I'll show. So both of them actually. So Claire actually what she did, she developed for this system for both of them for the using a Google Earth engine, because as Nishan mentioned in his presentation, that the Google Earth engine has this kind of application. So even what the script that we are sharing, you can convert the script into an application, so everyone can use it like this, you know, have like an input. That's what I said yesterday. I mean, in starting with having this user input that I was putting in the script, you can do this kind of a fancy interface. So she developed this for using Google Earth Engine and also putting in the website as well. So you have two models. So but just because this is not my research, but I'll try to explain as much as I know. So she used two models. A regression model. It's kind of like regression. I think the relation between the suspended sediment with different different pans of the remote sensing. And then she used also the ANN model, the artificial neural network. So you can go to any data, I think, and then you can download the data. But this was only for Bangladesh. So if you wanna probably create one for Sudan or something, I think you might be able to use the same approach. And I'd advise you to contact Claire. I can share the email with you, but she also has this paper. It's not in preparation because maybe she graduated, so she didn't update the website yet, but it's already published in the environmental modeling and software. So I think this will be a very good reference for you. I can share the paper with you. So I will try to share this paper with you as well. And I can send you, Ilham, the email or connect you with Claire so you can learn more about this system. And if you have specific questions actually about the sediment transport and remote sensing, there is a user manual here as well, but that's I think you can also go to the user manual and maybe read more about how it's working. But I think in general, maybe Nishan, if you have more, but in general, it's kind of using these two different models. I think if it's downloading the data will be Yeah, I think you are seeing here some differences. I think maybe we just need to.
Sorry, I just chime in here. I think, yeah, the images are maybe might not be available right now because the Landsat was
Okay.
cloudy or something. Yeah.
Okay, no problem. But I think the time series is there, so you can, you can see the time series. So I think the images is not available. Maybe it's not available, but it's. I can check with Claire as well, and I will try to connect you with Claire and share with you the paper, so you get an idea about how the system is working, or if you have more like kind of a specific questions on the sediment transport, because it's not my area, so I don't want to say something wrong. And you already have the.
Thank you so much.
Yeah, you already have
Thank
the
you so
file,
much.
so I don't want to say something wrong and getting more floods, you know. So let's yeah, I'll connect you and I'll send you the paper. Thank you, Ilham. So let's take the question from let me just go to the chat box. I think we have a question from Dr. Ashraf Mustafa from Ain Shams University. Can we have information about dams used for storing without releasing, the FP dams in Nile Basin, or we are only focusing on the Nile? So Dr. Ashraf, can you just can you just clarify a little bit about the dams storing without releasing, the FP dams and Nile Basin, or only focusing on the Nile? Can you just clarify a bit about the dams storing without releasing? Maybe I don't have a background on that, but you can just clarify a little bit about that, like or maybe the microphone is not working, or Nisham, feel free if you wanna come in and answer the question. I mean, the NiBRAS system in general is using the grant database, which is the existing dams. But yeah, Nishan, if you have something you want to say, or Dr. Ashraf, if you want to unmute yourself.
Yeah. Let me just give me one moment.
So do you mean the run of the river dam? I don't think so, because run of the river dam.
I don't know if you can...
Oh, Dr. Ashraf, yeah, we can hear you now. You can go ahead and yeah.
I think it's flood protection dams, right?
Only the flood protection, like they are. Dr. Ashraf, you mean the flood protection dams, or?
Yeah, like here, Ashraf is asking that can we have information about dams for storing releasing water?
Yes, but I have a very bad connection. I don't know if you can hear me or not.
We can, Dr. Ashraf. You can, we can hear you.
Yes, what I am thinking that
Nishan, let's. I think maybe it's just a kind of a delay. Maybe he will. I'm not sure it's a delay in the connection, or maybe you want to clarify more. But okay, Nishan, go ahead.
I think it is like we can get information about the dams that is just storing water, because anyhow we are using that area elevation curve and recent satellite imagery. So obviously we can derive the like storage variability of dams where there is no releasing. Then in that case, we can just constrain the equation that there is no outflow. That means outflow is 0, and we can just calculate the other parameters, other monitoring parameters. Yeah, it can be done.
I think maybe you maybe you're right. I think, I mean, in terms of the storage, using the same approach, using the remote sensing to kind of tracking the storage of the dam, it will be, I think it's okay. We can use it for this kind, for any dam. I mean, it doesn't matter if the dam is like releasing or not, but maybe in case if it's not releasing, then we don't need to use the water balance equation or this reservoir model to know how much water is coming out, I think so in this case. So I think, Dr. Ashraf, maybe I hope this answers your question, but if not, please, feel free to send me or Nishan or any one of our groups, and please send an email, and we can try to maybe clarify more our answer, or try to help in this question. So I think we can actually kind of, it's 10:45, so it's a kind of late. So maybe we can just take a 5-minute break. I think the last session would be a very light session. I just want to share with you some information, and as I said, one initiative that I created. So let's take maybe let's say maybe 10 minutes, so we can come back at 10:55. So let's reconvene at 10:55, and then we will try to finish by 11:30 everything. So thanks again, and please wait for us to the last session. And yeah, see you at 10:55.